Hello 3D printing friends! Today on the BV3D channel we'll take a look at the Kywoo Tycoon Max 3D printer. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about 3D printing, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're going to get a look at the Kywoo Tycoon Max 3D printer. Thank you, Kywoo, for sending this to me for review. The Tycoon Max is an interesting printer. I'll talk a bit about its specs while I get it unboxed and assembled. First off, it's got a build volume of 300 millimeters on the x-axis, 300 millimeters on the y-axis, and 230 millimeters on the z-axis. It's got a color touchscreen. It's got Wi-Fi printing. It's got a 32-bit Wham Nano mainboard with silent stepper motor drivers on the x and y axes and regular stepper motor drivers on the z-axis and on its extruder. Speaking of the z-axis, it's got dual z-axis stepper motors and it's got anti-backlash nuts on the lead screws. It's got a filament runout sensor and a BL Touch bed probe. It's got a textured glass bed that holds onto prints when it's hot and lets go when it cools. Oh, and that bed can get up to a maximum temperature of 110 degrees Celsius. It's got a direct drive extruder feeding a PTFE lined hot end that terminates in a 0.4 millimeter nozzle. And you can set it for a maximum temperature of 260 degrees Celsius. But with that PTFE liner, I would avoid doing that. The printer also comes with the usual assortment of things: microSD card and USB card reader, Allen keys, a nozzle wrench, a spare PTFE liner for the hot end, a little screwdriver, a spare end stop switch, a USB cable, zip ties, a couple of belt tensioning springs, a scraper, and yes, glory hallelujah, it comes with flush cutters. Thanks, Kywoo. All 3D printers should come with these. You did good here. Last, a cool feature of the printer is that it uses a linear rail on the x-axis and it uses smooth rods and linear bearings on the y and z axes. Assembling the printer was pretty straightforward. The y-axis, that's the part with the bed, bolts onto the rest of the printer with 4 screws. After that's done, you screw in the 2 rear leveling feet and plug in the y-axis motor, the y-axis end stop switch, and connect the bed heater and thermistor cables. Before we get into any of the using the printer stuff, I need to bring up a couple of safety concerns I encountered. First, while I was assembling the printer, I noticed that there were only 2 wires going into the power supply's input side. There should be 3: line, neutral, and ground. After all, the printer came with a 3-prong grounded power cord and has a 3-prong grounded power socket. But there was nothing attached to the power supply's ground terminal. Then I looked at the power socket and its ground pin didn't have anything connected either. So I fixed that issue by building a grounding lead. I crimped the appropriate connectors on the ends of a wire and connected the power socket's ground pin to the power supply's ground terminal. I also verified continuity between the power socket's ground pin and the power supply, as well as continuity between the ground pin and various exposed metal locations around the printer. And I asked Kywoo about it. They said that printers manufactured after the beginning of 2021 have the ground lead installed, and they also said customers whose printers don't have the grounding lead can request one, and they'll send it to you. So if you've got one of these printers, check to make sure the ground lead is attached. Probably the easiest way is to just look at the power supply through the open side of the yellow sheet metal panel. If there's something connected to the ground terminal on the power supply, you're probably good. I also found an issue with the high current wiring where the power wires come into the mainboard and go out to the heated bed and the nozzle heater. Checking the wiring meant that I had to remove that yellow sheet metal panel. So after removing a few screws and unplugging the screen's ribbon cable, I removed the panel and then I could get a better look at the wiring on the mainboard. And what I found made me unhappy. The high current power inputs and outputs on the Wham Nano mainboard use screw terminal blocks like pretty much every 3D printer I've used. That part is okay. The problem, well, one of the problems, is that there's almost no room for the power input and output wires. You can see that the wires have been compressed from being right up against that panel. There's a flat spot on the insulation where the panel presses against them. That's how close the wires are to the panel. And if there's barely any room for the wires, there's certainly no room for ferrules crimped on the ends of them. Anyway, I wanted to see if the ends of the wires were tinned, because using tinned wires with these screw terminals is a known problem. So I unscrewed the terminals to check the 24-volt wiring going into the main board. As I was doing that, I noticed that Kywoo is also powering one of the fans by having its power leads in the same terminals where that 24 volts from the power supply is coming in. And that's okay, I've seen that done before too. I don't think there's too much wrong with that. But once I got the terminals loosened and removed the wires, that's when I saw it. Huge globs of solder on the ends of the wires, and those fan leads were actually soldered onto those globs as well. Notice the flat spots on the solder? That's where it's been compressed by the screw terminals. So I also checked the wires that power the bed, and same thing, lots of solder and flat spots from compression. I've gone over why this is bad in a previous video. Check the description for a link or click this card up here. So what did I find on the wires for the nozzle heater? Bare, untinned wires. Okay, now I need to let you in on a secret. From an electrical standpoint, this is 100% perfectly okay. As long as none of the wire strands are sticking out and potentially able to short out against something, this is fine. Where it becomes a problem is in serviceability, and when you need to disconnect and later reconnect stranded wire from a terminal block in tight quarters, there's a chance of a stray strand of wire sticking out and then shorting out on something. That's why ferrules are my go-to choice for stranded wires and terminal blocks like this. Ferrules keep the strands corralled, and ferrules don't compress under the clamping force of the tightened terminal. But if, as in this case, you can't use ferrules because there's just no freaking room for them, using bare stranded wire is the safest thing you can do. And so that's what I did because I really didn't have a choice. I snipped off the solder globs and stripped the insulation from the ends of these wires. Then I carefully inserted them into the terminal blocks and tightened them down. With all the other metal-to-metal contact between the power supply and the metal panel and the printer's frame, and yes, I know a lot of that contact is probably due to screws going through the parts, it's at least better than it was. Once I had the wiring issues taken care of, I put the yellow panel back on the printer. So, I brought this tinning the ends of the wires thing up with Kywoo, and their position on the matter is that the solder globs provide a large connection area when compressed, and that it's good for high current connections. But when a manufacturer of this type of terminal block has a white paper dedicated to explaining precisely why this is a bad idea, complete with diagrams, you have to wonder why printer manufacturers keep doing this. Okay, so let's talk about the user interface now. The 3.5-inch color LCD touchscreen responds nicely to touch, and the user interface is reasonably well designed, although it does have a few quirks, and we'll get to those in a moment. There are three main buttons on the home screen. These are Tool, Settings, and Printing. The manual does an excellent job of showing all the features, but here's a quick overview. In the Tools screen, you'll find buttons for preheating, filament loading and unloading, moving the X, Y, and Z axes, homing the printer, and performing a mesh leveling operation. In the Settings screen, you'll be able to connect to a Wi-Fi network, turn the part's cooling fan on or off, find the version number of the firmware installed on the printer, and switch the user interface to one of several languages. In the Printing screen, you'll be able to select a file from the microSD card and start printing. And this is where things get a little quirky because the printer shows you every single file and folder on the card. So things like the hidden system volume information folder that Windows puts on the card, you'll see that. Hidden files that other operating systems like to put on removable media, you'll see those too. Folders, yep, you'll see those too, but that's actually cool. Some printers won't let you use folders to organize files. But the names on them can be kind of weird. Kywoo has numbered folders with names like 1.instruction manual, but on the printer that just shows up as 1.g. File names are shown with a maximum of 15 characters with a tilde at the end of the name if it's longer than that. So that's the quirky bit of the user interface. Personally, I think it would be better to have a list of files instead of a grid of icons. This would allow more room for file names to be shown and make it easier to select a file for printing. Before you print for the first time though, you'll need to go through the process to home the printer and auto-level the bed. Fortunately, the manual does a good job of walking you through that. Interestingly, the printer does its homing differently than I'm used to. For instance, the X-axis homes by moving the carriage to the far right, and the Y-axis homes by moving the bed fully forward. And of course, with the BL Touch, the Z-axis homes in the center of the bed. As for auto-leveling, when we use that term, we're not really leveling anything. particularly on this printer because the bed has no adjustment knobs like other printers. And actually that's a good thing because there are no adjustment knobs to get bumped accidentally and no springs or anything, so there's really nothing that can get out of alignment on the bed. So what does auto leveling mean? It means that the printer uses its BL Touch to probe the surface of the bed in a grid pattern to determine where it may have high or low spots. It automatically saves that information and uses it to generate a mesh, which is like a topographical map of where the high or low spots appear on the bed. Using that mesh information, the printer can adjust the Z-axis during a print so the nozzle always stays the correct distance from the bed. According to the manual, you shouldn't need to run the auto level process again until you change the nozzle or change the bed surface. So after completing the home and auto level steps, it's time to load some filament. Now I could use the automated filament load feature, but since this is a direct drive extruder, it's easy enough to load it manually. I'll preheat the nozzle to 200 degrees Celsius. While I'm waiting for the nozzle to heat up, I've put a spool of filament on the spool holder. And I've cut a 45-degree angle on the end of the filament and inserted it through the filament detector and then into the hole in the filament loading lever. Just press that lever down and you can push the filament in. Once the nozzle is up to temperature, I can turn the red knob on the front of the extruder in a counterclockwise direction, which will turn the extruder stepper motor and push the filament down into the nozzle. Once you see filament squiggling out of the tip of the nozzle, you're done loading. With the filament loaded, the next step is to set the Z offset. Setting the Z-axis offset is a fancy way of saying that we need to fine-tune how high the nozzle is from the bed to get a good first layer. The manual instructs you to print a leveling test that's included on the card, and basically what that does is print a series of square outlines. While those are printing, you use the touchscreen to adjust the Z offset up or down until you're happy with it. There is a just right range where the filament isn't too squished, but it still sticks, and that's what you're aiming for. And again, that's reasonably well documented in the manual. Now that the Z offset has been adjusted, let's print one of the files that came on the card with the printer. There are 4 pre-sliced G-code files ready to print. One of them is the auto leveling test file. Another is an XYZ cube. It looks like the standard 20mm cube, but it's scaled up to 30mm. There's also a bird whistle that takes 2 hours to print, and a ghost you can hang on a keychain that only takes 30 minutes. I printed the XYZ cube, which took an hour and 15 minutes. It came out pretty good. The top is really quite smooth, though there are a couple of scars where the nozzle dragged across it to get into and then out of the top and bottom corners of the Z. And I don't see any ringing to speak of on the X and Y axes, so all in all, pretty good print quality. Okay, so that was one of the files that Kywoo sliced for us and put on the card. But what about slicing other files and printing them? You know, the kind of stuff you've downloaded from Things or Thingiverse or made yourself in a 3D modeling app? Well, for that you need to use a slicer. On the card, Kywoo includes Cura 4.5.0 for Windows, but of course you can go download the current version of Cura from Ultimaker for Macs, Windows, or Linux computers. As of this recording, it's at version 4.12, and there's a link in the description. And Kywoo has a PDF guide on the card to show you how to add the Tycoon Max to Cura. Well, the guide says to set the bed size to 240 by 240 millimeters, but that should be 300 by 300 millimeters. The short version is tell your slicer the printer has a 300 by 300 millimeter bed, and its Z-axis can go up to 230 millimeters, and it uses 1.75 millimeter filament, and it has a 0.4 millimeter nozzle, and it has a heated bed. Oh, also in the PDF guide, Kywoo suggests setting the retraction to 7 millimeters. That seems like a very large value for a direct drive extruder. I figured the retraction should be significantly lower, probably somewhere in the 2 or 3 millimeter range. But I did a lot of testing, and what I found worked best for me was a retraction length of only 1.5 millimeters at 30 millimeters per second. So I sliced and printed several models, and I think they came out quite good, with just a couple of exceptions. This, where did it go? This is a retraction test, which I printed after having settled on that 1.5 millimeter, 30 millimeter per second retraction value. There's a little bit of wispy stringing, but not much, and the columns themselves came out very well formed. Next up is a nice benchy. I don't really see much of anything wrong with this at all. Even the little nameplate on the back is almost readable if you get the lighting just right. And here's a little Calicat model, which is pretty good, but it does show some cooling related issues on the tail. This might also just be a filament related issue. I did print another Calicat with different filament and got a better result. On both there are just one or two little strings, and that's fine. Now here's Luby 3D's Aria Dragon, and she came out great. Just an amazing model, and the printer really did a good job on it. And last, here's one of those printer capability test models. This tests all sorts of things in a convenient, takes a while to print model. It tests tolerances with these cylinders and holes. I was able to pop out the cylinders on all but the one with the 0.2 millimeter gap between the cylinder and the hole. I think that's pretty good. It also tests the ability of the printer to handle overhangs with these 45, 30, 20, and 15 degree overhangs. The 45 and 30 degree overhangs printed perfectly. At 20 degrees, you can see it's starting to struggle just a tiny bit, and the 15 degree one looks a little sloppy. But for unsupported overhang angles, even at 20 degrees, it did really good. Another test on this model is bridging, and that's maybe more of a function of parts cooling than anything. The undersides of the longer bridges on this part tended to droop more, but the tops of them all came out fine. There's a stack of cylinders, and underneath there's another test of unsupported bridging. That's a little rough, but not too terrible. And here's a platform that gets built up, and at the very top are 9 thin, very tall cones. The taller and thinner they get, the more susceptible they are to stringing. But you know what? The printer was able to print them all the way up to the top, so I think that's a win. I think at a certain point there are just some model geometries where you're going to get stringing no matter what. And really, I think that's what this model is trying to show. But overall, these seem to come out really good. So now that we've had a look at the print quality, here's what I think is good about the printer. First, I like that it includes a bed probe. A lot of 3D printer beds are not perfectly flat, and so when you try to get them adjusted, they may be perfect in the middle, but then the nozzle is too close or too far away out toward the corners. With a bed probe, the printer is able to compensate for that, so you get a consistent first layer on your prints. The fan noise isn't bad. The parts cooling fan is nearly inaudible. The hot end fan, while on full time, is reasonably quiet. The loudest fan on the printer is the one in the Meanwell power supply, but that one only turns on when the power supply starts getting warm. Overall, the printer seems much quieter than an Ender 3 series printer. The design of the printer is pretty unique. Some will say it looks like a Lulzbot Taz, and it does have a fair resemblance to that printer. It has a rectangular prism frame with the bed moving back and forth at the bottom of it. But the Taz is a more industrial level printer with easily swappable tool heads and other things, and of course a price that aligns with those capabilities. That said, the Tycoon Max looks very different from the vast majority of i3 style Cartesian bed slingers, and I kinda like it. I think it's interesting, in a good way, that Kywoo is experimenting with the design. The Z-axis and the Y-axis are both riding on smooth rods, while the X-axis uses a linear rail. The inclusion of the knob on the extruder is a nice touch. It makes it easy to manually feed filament into the system, and it also serves as an extruder visualizer, showing you when the filament is feeding and retracting. And it has carrying handles to make it easy to move the printer around. The touchscreen's interface responds accurately to touch input, and the color choices are nice as well. So that's what I like about the Tycoon Max. Now, here's what I don't like. There are a few little quirks in the user interface related to how file and folder names are displayed. Using short file names will make your life easier because you'll be able to see the whole name. At 230 millimeters tall, its build height seems short for a printer with a 300 by 300 bed. Most printers with a bed this size have a build height of about 400 millimeters. Putting that into perspective, the Tycoon Max's build height is shorter than an Ender 3's. So that's the Kywoo Tycoon Max 3D printer. It does a good job printing, and it has a lot of nice features, but I feel like for the price, the wiring should have been a little more on the safer side of things. I think if Kywoo made the case about 20 millimeters deeper, the main board wouldn't be so cramped in there, and then there would be plenty of room to use ferrules on the ends of the wires. That said, simply snipping the tinned ends off the wires, stripping off a bit of insulation, and carefully inserting them into the screw terminals mitigates that issue. But that's kind of my point. While it's an easy thing for a customer to fix, for the price, you shouldn't have to do that. Well, 3D printing friends, that's about all the time we have for this episode. And now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great, and if you'd like to help support the channel, check the description for ways you can do exactly that. And hey, if you haven't already subscribed, please do. It's absolutely free and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.